Hello, this is the lecture number 1 for the chapter integration. We are starting today, and first of all we'll discuss what is the integration is and what is the meaning of the integration, and we'll discuss some basics and the formulas for the integration, basic formulas for the integration. Now, what is the integration? Integration is a inverse of differentiation, or we can say that integration as an inverse, yeah, antiderivative of our differentiation. Now, if d upon dx of phi x is equal to fx, that is the derivative of function phi x is equal to fx, then the integration of fx with respect to x is equal to phi x plus c, where c is any real number and it's called the constant of integration. Now we'll discuss after some time why we are putting here c and what this means c here, or this known as the constant of integration or arbitrary constant. Here the function fx is called the integrand function. Integrand f dx is called the element of integration. Fx is the integrand is known as, and fx dx is known as the element of integration, that is the element we are integrating. And the symbol, this sign, is stand for the integral. The function phi x is called the indefinite integral. This is the indefinite integral, or simply an integral. The derivative of a function is unique. You have done in the derivative chapter that the derivative of a function is unique, whereas the integral of a function is not unique. I'll explain it to you with example. A function has more than one antiderivative, each is differing from other by a constant only. Now I'll tell you why the derivative of function is unique and why the derivative integration of a function is not unique, and why we are putting this sign constant of integration. Now let us take an example that derivative, if you find the derivative of sin x plus 3, it is equal to cos x. You know it, the derivative of sin x is cos x and derivative of constant is 0. Similarly, the derivative of sin x plus 4 is equal to cos x, which is unique. That is, it is a unique only. We cannot have two derivative of a single function. Now, as we have just told you that integration is the reverse process or the antiderivative, then it means the integration of dx should be equal to sin x plus 3. But if we find the integration of cos x, it is equal to sin x, and we are putting it as c1. Because why putting this here? Because if I have just told you that that it is the antiderivative or just the reverse process of derivative. So derivative of cos x, because cos x is the derivative of sin x plus 3, so the integration of this cos x must be sin x plus 3, but we are getting only sin x, so we are not getting this 3. So I put it this c1, which is not unique. We cannot tell after integration that what is the this constant of integration. And derivative of sin x plus 4, I've just changed this constant, it is also cos x. And if I find the integration of this, I should obtain this sin x plus 4, which is only equal to sin x. So I'm not getting this 4. That is why I put this c1 and c2, and this is not unique. They are different for the same integration. Cos x, we are different. So this is why we are saying that the integration of function is not unique, and because we are not getting this constant, that is why we are putting this c1 and c2, that the constant of integration, and that is why is known as the indefinite integral, because the integration of the function is not unique. Because I'm again telling you why we are putting this constant sign, because the derivative of this function is cos x, and I'm finding the integration of this function, I'm not getting this 3. So for this 3, I'm putting this c1, which is the arbitrary constant. It can be 0 because the derivative of sin x is cos x, and if I find the integration of this cos x, if I find the derivative of sin x, it is equal to cos x, and if I find the integration of cos x, it should be sin x. If I put c there, then it means the C is 0. It can be 0 or what. We will not get this C if we find the integration of this cos x. That is why similar in this example, if I find the derivative of sin x plus 4, I'm getting cos x. If I find the integration of cos x, I should obtain this sin x plus 4, which I'm not getting. So that is why I'm putting this value C2 for this constant 4, which is not unique, or which I'm not getting exactly what is there here in this example. Now we will discuss the elementary formulae or the integration of integral of some basic functions. Now the integration of x raised to power n is equal to x raised to power n plus 1 upon n plus 1. Because why I'm putting C, I've just explained to you why I put in here the C sign. Now why I obtain this? Because if I find the derivative of this function, I will obtain this x raised to power n. See it, the derivative of x raised to power n upon n plus 1. You know how to find the derivative, x raised to power n plus 1, n x to the power n minus 1 upon n plus 1, which will cancel out. It is equal to x raised to power n. Because I've just explained to you, because integration is just the antiderivative or the inverse of a differentiation, or just the reverse process of differentiation. Now because the derivative of x is 1, so the integration of 1 should be x. I've just write it here. This formula you have to learn. Now because the derivative of log mod x is equal to 1 upon x, therefore the integration of 1 upon x should be equal to log of mod x plus c, because log is defined for the positive values. Now because the derivative of a raised to power x upon log a is equal to a raised to power x, therefore you know the derivative of a raised to power x upon log a. How you to find? If you don't know, so first of all do the chapter of differentiation, then come to the integration. So because the derivative of a raised to power x upon log a is coming out to be a raised to power x, therefore the integration of a raised to power x is equal to a raised to power x upon log a. Now because the derivative of e raised to power x is equal to e raised to power x, therefore the integration of e raised to power x is equal to e raised to power x plus c. Now because the derivative of minus cos x is equal to sin x, so therefore the integration of sin x is equal to minus cos x plus c. And like this you can derive the formulas of some basic integration function. Derivative of sin x is equal to cos x, so therefore integration of cos x is equal to sin x. Because the derivative of tan x is equal to sec square x, therefore the derivative of integration of sec square will be equal to tan x. Because the derivative of minus cot x is equal to cosec square x, therefore the integration of cosec square x will be equal to minus cot x. Similarly, derivative of sec x into tan x is equal sec x is equal to sec x into tan x, therefore the integration of sec x into tan x will be equal to sec x plus c. Because the derivative of minus cosec x is equal to minus cosec x into cot x, minus here sign, so it is will equal to cosec into cot, so integration of cosec x into cot x will be equal to minus cosec x. Now because the derivative of sine inverse x upon a is equal to 1 upon under root 1 minus x square upon a square into 1 upon a is equal to under root a square minus x square, so the integration of under root a square minus x square will be equal to sine inverse x upon a, and so on. So these are some basic integration of some functions which we have to learn it here like this. Now after that there is a geometrical meaning of the indefinite integral. Again we'll explain why we call it an indefinite integral. Now because if the derivative of phi x is equal to fx, then integration of fx dx will be equal to phi x plus c. For the different values of c, will get the different function differing only by a constant. Now what is the meaning of this? Now we are obtaining this function phi x plus c for the fx dx will be different. This function will be different for the different value of c. If we get different function differing only by this constant c, the graph of the function give us the infinite family of curve. Now if we draw the graph of these function, will get infinite curves, and such that at the point on these curve we with same x coordinate, the tangents are parallel as they have the slope phi x. Derivative of this function is equal to fx, because the derivative function is this then the integration of this function is 5x plus c, and this function will be different for the different values of c. So we'll get infinite curves. I'm taking an example. Now let take the integration of 1 upon root x with respect to x. So it will be root x plus c, where c is any real number. Now it comes out to be this function fx is comes out to be root x plus c. Now this is a parabola. Why it is a parabola? Let us take the diagram for it. Now because integration of this 1 upon root x is equal to root x plus c, and if I take is equal to this root x, and it will be a parabola, that is y square. It will be a parabola like this. It will be a parabola. Now if I put it here plus c, so this parabola will not pass through the origin. It will be passing to the different points for the different values of c. Now let us take an example. Now this curve. Now y is equal to root x plus c for c is equal to r. Now if c is equal to 0, then this curve parabola will be passing through the origin like this. Now if the value of c is minus 1, then it will pass the turn at the minus 1 like this. It will get a parabola like this. If the value of c is 1, we'll get a parabola passing through the origin. 1. If c is equal to 2, we'll get the parabola passing through this 2, and so on. It means we are getting infinite numbers of curves for this infinite values of c, and if we draw tangents at these curves, they will be parallel to each other. So that is why this integration is known as the indefinite integrals, because we'll get infinite numbers of curves for the different values of the constant of integration, which we call it a arbitrary constant, and like this. That is why it is known as the indefinite integral. So before going to the exercise of this chapter, you should learn the formulas we have discussed just before this graph. Then you will able to do these types of simple integration in the beginning. Okay, we'll discuss in the next lecture. Thank you.